Hi and welcome to this On Maths prediction for the AQA Paper 1 May 2018 paper. Enjoy! Hi and welcome to this On Maths prediction. So what we're going to do in this prediction is go through a predicted paper for the upcoming exam. Now what we mean by predicted paper is what we've done is gone back through the two exams that have already been sat for this, June and November last year, and we've picked out topics we think will come up again, and we've also picked out topics that didn't come up again. We've also looked through all the literature released by the exam board so that we can have a look at what they're hinting at will come up. And they've dropped some hints so far about certain aspects of this paper, which we've picked up on and put into this predicted paper. Now, this is, I think, the third year we've been doing predicted papers, and I say this every single year, and I hope that people are listening, which they clearly are, I hope. This predicted paper is not a be-all and end-all. Please don't use this as this is my one thing I'm going to do for the exam. I don't think anyone does, but I'm going to say this anyway. Use this as a revision strategy, just like you'd use a revision guide and anything else. It's a good way of just testing how your revision's going. And what a lot of people last year did was they did the test, had a go at it, see what they got, and then did the test a couple of weeks later to see if they've raised their grade. And just regularly doing the assessment will help you judge kind of what grade you're at. Now we construct these papers so that they're balanced by topic. So it's the example would say what percentage of each topic should be on the paper. We also balance them by assessment objective, basically difficulty of question. So they're balanced between AO1, AO2, AO3. If you know what that is, then brilliant. If not, don't worry about it. They're also balanced about grade. So the example would say roughly how much of each grade. They give it categories, but they're balanced along those. So it's an accurate paper in that regard. There are some questions that involve drawing and things like that we can't do perfectly, but hopefully we do it in a way that you definitely know how you'd use a compass or a protractor if you were asked to do that physically on paper. Now, those of you who've done predictions with us before would know that this entire paper is available on our website completely for free for you to try, and you can do it online. You can even register to save your scores, so you can have a go at the paper, come back a week later and remember what you got and see if you can beat your score. The website and this video will keep track of the grades as we go on, and on the website it shows you what grade you're at so far, and the difference between what your grade is and the maximum amount you could have got on the paper so far. So it's a really good tool to kind of judge what you need to do to get a grade 4, 5, 6, 7, 8, 9, whatever grade that you're looking for. The website also includes loads of other stuff. I'm not going to be able to go into all of it, but we've got topic busters are the main ones, which is every single topic at the new GCSE, and you can just go through and practice any topic you like. We've also got Demon questions, which are the hardest exam paper questions. I was talking about assessment objectives earlier. These are AO3, which is the hardest ones. They're problem-solving questions generally, and they're the ones that students struggle with the most. So we've got Demon questions that you can just practice the hardest ones. Now, obviously, there's lots and lots and lots more on the site, so please check the site out after you've watched this video. We also have a supporters club, which comes with a few extra perks. Obviously, everything on the site is for free, but one of the perks we're looking at including, and probably have by the time you watch this video, is a PDF download of some of the papers, including this paper. So if you want to consider supporting us, please check the link that's probably come above my head right now. So if you like this video, please click like. If you don't, obviously click unlike, and please consider subscribing. We're going to release the paper 2 and 3 papers just after paper 1 for paper 2 and just after paper 2 for paper 3. Those are more accurate predictions because obviously we can take off the topics that have already come up. I hope you enjoy this video. Thank you. The rule to remember when you're dividing fractions is KFC. Keep the first fraction the same, flip the second fraction, and change the divide to a times. So I'm going to rewrite that. I'm going to keep the first fraction. I'm going to flip the second fraction, and I'm going to change the divide to a times. And then when you're timesing fractions, you times the top, so 1 times 7, and times the bottom, so 11 times 2. So it's 7 over 22. So this graph is showing how much a taxi charges against the distance travelled. And it asks us to interpret the y-intercept of the graph. Now the y-intercept is going to be this point here. If you notice, this is the point and when the distance is 0. In fact, the y-intercept is always when this thing here, which in this example is distance, is 0. So if you think about that in terms of hiring a taxi, that's how much you're charged before the taxi even travels anywhere. So sometimes we call it a standing charge or an initial charge. So the initial charge is, and then read off what it is, where it's £5. Okay, so for this question, we've basically got the mean of the numbers. We know what 3 of them are, but we don't know what the 4th one is, because the numbers rubbed off. Okay, so first thing for this question is think about how you would work out the mean. You'd work out the mean by adding these numbers together, and then getting that answer and dividing by the amount of numbers we've got, which is 4. And we know that equals 12. So if I put an algebra letter in, so let's call it x, then I can write that down. So 9 plus 6 plus 15 plus x, which is our unknown, divided by 4 equals 12. Okay. Now if I put my lines down and just try and solve it, first thing to do is I'm going to times both sides by 4 to get rid of that divide by 4. And I'm going to add these numbers together because we know what the answer to this is. So 15 plus 6 is 21, 21 plus 9 is 30. So 30 plus x, and we've got rid of the divide by 4 because we've timesed it by 4, equals, and then 12 times 4, which is 48. Okay, next thing to do is take away that 30. So we've got x equals 18. So I know the answer is 18, but I can check that just to check whether I've got it right. So 9 plus 6 plus 15 plus 18 is going to be 48. 48 divided by the amount of numbers, which is 4. So 48 divided by 4 is 12. So that's my answer. Now, you could have done that through just trying different numbers out, but imagine in the exam, maybe the numbers are going to be a lot bigger. So this method is probably the quickest, but there are other methods, other ways of doing it. Whenever answering questions involving ratios, always just double check that you read the question, because here it might look like the total is £35, but if you read the question it says Adele and Bert received £35. Now, to do this question, we've got to first of all work out how much Adele and Bert are getting in the ratio, how many parts. So Adele gets 3 parts and Bert gets 2 parts. So A and B parts equals 3 for Adele and 2 for Bert. So that's 5 parts in total that they get. Now it says they receive £35, so we need to work out what 1 part is worth. So to find out what 1 part is worth, we do the £35 that theirs is worth, and we divide it by 5 because they have 5 parts in that ratio. 35 divided by 5 is 7. So 1 part is worth £7. Now Chris has 6 parts, so Chris, we're doing now, he has 6 parts. So we do 6 times the £7 that each of his parts are worth, so it's going to be £42. And it's really easy to make mistakes with ratios questions by not reading the question, so just make sure you double check that you understand what the question's asking. Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12, and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10. And that is the same as that. So we know that x equals 11. And that's it. Question B. Have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well, that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. Okay, so in this question we're on a school trip, and it's best to break this question down into bits we need to work out. So it says 4 buses each carry 105 students. So the first thing I need to work out is how many students there are in total. It says 35% of the students are bringing their own lunch, so we don't need to worry too much about those students. A seventh of the students are buying lunch when they get to the theme park, and the question just basically says how many have not made plans for lunch. Okay, so find out how many students have not made plans for lunch. So they're not bringing their own lunch and they're not planning to buy lunch there. So let's do the first thing first, and let's work out the total total amount of students, and show the examiner what you're working out each time. So we're going to do 105 times by 4. You can do that any method you want, but it's going to be 100 times 4 is 400, 5 times 4 is 20, so it's going to be 420 students. So we've got 420 students in total. So next we need to work out how many are bringing their own lunch. So bringing lunch. Okay, so to do this, we're going to work out 10% first, which is going to be 42. Because if 100% is 420, that's how many students we have. 10% is, you just divide it by 10. And next we can work out 5%, which is going to be half of that, so it's just going to be 21. Next we need to work out 30%, because we need 35%. And all we do is times the 10% by 3. And again, I could do a bit of working out for this. So 42 times by 3. And you can use any method you want. A lot of you probably prefer doing the grid, which is absolutely fine. So 40 and 2 and 3. Obviously, if it's on the calculator paper, you can obviously just use a calculator. But either way, you get 126. So it's going to be 126. Now 35 would be these two added together. So it's going to be these two added together, because 5 plus 30 is 35. So 35% is going to be, and I can do a bit of working out here, so 126 plus 21, or the other way around, 741, so 147. Okay, so 147 students are bringing lunch. Next, so buying at park. So students who are buying at the theme park. It says a seventh of the students. So to find a seventh, all we do is we get the amount of students, which is 420, and we just divide it by 7. And again, you can do this any way you feel comfortable doing, although this is a bit easy because 42 divided by 7 we know is going to be 6. So 7s into 4 don't go, so carry that on. 7s into 42 are 6, 7s into 0 is 0. So it's going to be 60. So students left. So we're going to do the amount of students, which is 420, take away the people who are bringing lunch, plus the people who are buying it in the park. So we need to work out what that is. So it's 147 plus 60. So 7 plus 0 is 7. That's going to be 10. And so that's going to be 207. And finally we need to work that out. So 420 take away 207. So you can't do 0 take away 7, so we nick 1 there. 10 take away 7 is 3. We need to nick 1 there as well. So 11 take away is 0. Oh no, I don't need to nick 1 there, do I? So we've just got 1, so that's 1. 4 take away 2 is 2. So the answer is 213. Now it's really important that you set your work out really logically. Any working out you do, try and keep it near where you've done done the calculation, written the calculation down. So I'd probably put this down here if I had like a piece of paper in front of me. Obviously I've moved these around slightly just to make them a bit clearer, so I'm not constantly scrolling. The headings are really helpful. So as an examiner, if you've headed all of your working out, it's really easy to spot what you've done and give you credit for it. So just make sure you set out your working out neatly and logically. Okay, so for this question, it's really common to take the wrong approach with this. For instance, the biggest wrong answer for this is to try and get from 6 to 4. So we can divide it by 3 and then double it. So we're going to divide the days by 3, which is 4, and then double that. So the most common wrong answer is 8 days. And I understand why people put that answer down, but think about it logically. 6 people take 12 days. 4 people, which is less, so you imagine there's a task and you've got 6 people and then you've got 4 people, okay? You'd expect it to take longer. So if it took 12 days before, it wouldn't suddenly take 8 days. Otherwise, why would people employ more people? Why would a foreman employ more builders if less is better? So we know that that's the wrong answer. How do we work out the correct answer? Well, there's a really simple way of thinking about this, and it's to think about this thing I'm just making up now called people days. So every job has an amount of people days. Okay, and to work out the amount of people days for this, you get the amount of people, which is 6, and you times it by the amount of days it takes, which is 12. So 6 times 12 is 72. So it's going to take 72 people days. So for instance, if we had one person, which we could have, it will take that one person 72 days. If we had 2 people, it would take them half of the 72. So it says we've got 4 people. So what we do is you get the amount of people days, which is 72, but we don't have one person anymore, we've got 4 people, so we're going to divide it by 4. Now an easy way to divide something by 4 is to halve it, then halve it again. So 72 divided by 2 is 36, then halve it again is 18. So the answer is 18 days. Now let's have a look and see if that's realistic. Well, it took 6 people 12 days, so 4 people, which is less, will take longer. So instead of 12 days, 18 days. Now there is an assumption we've made, and that's that all the people work or paint at the same rate. Now it could be that the 6 people we originally had were kind of lazy, not very good at painting, had other distractions, and the 4 people we had are amazing people at painting, and actually maybe they did take less time. Or it could be that it rained when the 6 people tried to do it, and it didn't rain when the 4 people tried to do it. Don't get too creative with your explanations. They're looking for just some understanding that this is what we call in maths a model for working stuff out, and it doesn't always work. Because whenever you're working with people, people are different. We're all different. We've each got our individual differences. So anything that says that the people might not work at the same rate, absolutely fine, we'll get you the mark. Now this question looks a bit complicated, but the easiest or best way of approaching it is kind of put the question to the back of your mind and just try and write down all of the angles and the reasons for them that you can. So the first one I'm going to label is this one. I know it's a right angle because angles on a straight line equal 180. So therefore I can work out this one here. Because there's a triangle there, one with 26 degrees, one with 90 degrees, we can take them away from 180, and that will give me, so let's do that now, and that will give me 64. And it's important to write down the reasons. So angle BCA equals 180 take away 90 plus 26 equals 64 degrees. Angles in triangle equal 180, and I'd write it in words for the actual exam. Okay, next thing I realise is that the x here is equal to the angle here, so this is also x, so angle BAC equals x, and the reason for that is z angles, although you have to use the right word, just alternate angles. Okay, the next bit, if you have only used the diagram and not read the question, you're going to have real problems because you can't answer the next bit without reading the question. This bit here in the question is critical, the fact that AB is the same as AC, so that length there and that length there are equal. Now something we do know about isosceles triangles, which this is that bottom two angles are equal, they are the same. Therefore, the next bit I can write down is angle ABC is going to equal 64 degrees as well, ISOS, because it's an isosceles triangle. Now, we've got all of the angles, so we know that x plus the 64 at the bottom plus 64 on the right hand side, so 64 on the left hand side plus 64 on the right hand side, we've got the 64 there from the previous question, equal 180 degrees, because again angles in a triangle equal 180 degrees. Equal 180 degrees. So we can finish it off by solving it. So I put my lines down. So we add 64 and 64 together, which would be 128. So x plus 128 equals 180. And we're going to take away the 128 from both sides. So we do 180 take away 128, which is 52. Now this isn't the only way of doing this. There are other methods. You could have tried to find this angle here, and those of you who are really good with algebra can try and understand why x will always be twice the angle here. So that's a little bit more of a challenge for you if you want to do that. So when conducting a survey, you've got to make sure that you are looking into a few areas. The first area is to make sure that your questionnaire is fair, that it's not swaying the person's opinion with leading questions. The second thing you need to be careful of is that your sample is what we call representative. It means that everyone from all different areas have a view. So for instance, if you were looking at investigating the school canteen and you only picked people who used the school canteen, then it's probably going to be swayed towards how wonderful the canteen is, rather than the people who don't go to the canteen, who probably don't go because they don't like the canteen or because they bring packed lunch. The other thing that you need to look for, and there's quite a long list, but the other main thing you need to look for is that your sample is big enough. If it's too small, then it can't possibly be representative. So when it says select 5 names, 5 people is not enough for a proper survey. So my answer to this is step 3, and I would say sample is too small. Okay, this question looks quite confusing because it says the weight of the sack is 19 kilograms, but then it asks you for the smallest and largest possible weight that it could be. So it seems quite confusing at first, until we realise that it is rounded to the nearest kilogram. So the first diagram I draw out is just a line, and I put 19 in the middle. And I think to myself, right, what was the next one down that it could have been? If it wasn't 19, if it was less, what's the next one down it could have been? Well, the next one down would be 18. And then I think, well, what's the next one up it could be? Well, it could have been 20. It's not 18 or 20, it's 19. And then I think, well, what's the cutoff point between 18 and 19? So I draw a line down here, and the cutoff point would have been 18.5. So if it was 18.4, it would have been rounded to 18, but 18.5 or more, it's rounded to 19. And I do the same on the other side. So I draw a line between here and here, and this time I think, right, what's the cutoff point for this one? Well, that's 19.5. Now, this second one's a little bit more complicated, because you might think, oh, actually 19.5 would round to 20. So it's 19.49 recurring. Yes, you would actually be true. Unfortunately, 19.49 recurring is actually the same as 19.5. So, for our smallest possible weight, we put 18.5. And for the maximum possible weight, we can actually put 19.5, even though we know that would have rounded to 20. Now, this works because it's a continuous scale. If you were doing an amount of counters, say if it was 19 counters, or I don't know, 190 counters to the nearest 10, then the lowest one would be 185, that would be fine. But the highest it could have been before it was rounded to the nearest 10 would be 194, because you can't get like a 0.1 of a counter. So just be wary of that if you're working in discrete calculations, so things that can't be 0.00001 or something, then you do 4 at the end of it for the maximum. But if you're working with heights, weights, things like that, then 19.5 for this one is absolutely correct. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, so the most important word in this question is this word here. As soon as you're asked to estimate something, it means you're going to round all of the numbers to normally one significant figure. There are a few exceptions like square roots where you round it to the nearest square number. So we're given this formula here, and we're given 4/3 times pi times r cubed. So what I need to do is write down what I'm rounding everything to first. So that pi, we know pi is 3.141 blah 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 blah. So I'm going to round that to 3, and I've done a mistake there. I've said equals, and what I should write is a kind of little squiggle equals, meaning roughly. Okay, and r is roughly, well, it says radius is 3.22, so that's roughly 3 as well. So we're going to do 4/3 times pi, which we're saying is roughly 3, times 3 cubed. So when I do that, now if you notice, the divide, the over 3 there and through one of the 3's there will cancel. So we're going to do 4 times 3 cubed is 3 times 3, which is 9, times 3 is 27. And so we're going to do 4 times 27. So 4 times 27, which would be 4 times 7, plus 4 times 20, which is 108. Now there's a few things to notice. I could have rounded the 4/3 just to 1 and then just done 27 times 3. That would give me a slightly different answer, but that's still technically correct. You've just rounded the 4/3 to 1. They are quite liberal with what you round with these types of question. Pi is a nice easy one to round because that will always, for an estimation question, always round to 3. Now it says, is it an underestimate or overestimate? Well, pi was rounded up, so was rounded down. And the radius was rounded, it was 3.22 and we've rounded it down. So if you think about it, it's two numbers that are too small multiplied together, and one of those numbers is cubed, so it's going to be an underestimate. Now be careful, if there's a division in the question, you'll end up with a situation that it's going to be the opposite for the bottom number. So for instance, a over b, if we rounded b down, that would actually end up with a bigger number. So just be careful with division and subtraction with these, but when you're adding or multiplying, if you're rounding them both down, it will be an underestimate. Okay, for Venn diagrams, it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1 over 4, or a quarter. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient. So the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these A and B. Looking at this, if I double A, then the x's would become the same because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2A. So I'm going to double everything in A. So double the 2x to make 4x to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now, next, I need to probably, and it's normally the case that if I write down B again, it just makes things easier. So I'm just going to literally copy down B underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add. And it's that simple. Okay. Now the signs are the same because they're both positive, so we are going to be subtracting. So a minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now two minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the two minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4, so 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit. And x equals 2. Now if you've got time in the exam, you can check that that's right by using the second equation. So 4 times 2 is 8. 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. Now both these questions just rely on you remembering the rules. The most common wrong answer for A is 50. Anything to the power of a half is a square root. So the square root of 100 is 10. So the answer is 10. Now you could have had plus or minus 10, but for this question they normally aren't that fussed about having the negative version. Anything to the power of negative, again, the most common wrong answer is something like minus 16 or something like that. Negative just means you flip it. So the number 4 on its own is just 4 over 1 as a fraction. So if we're flipping that, it becomes 1 over 4. But because it was minus 2, that 2 stays with the 4, so it's still 1 over 4 squared. 4 squared is 16, so it's just 1 over 16. Now it could have the word evaluate in either of these questions. Okay, this is a basic circle theorem question. And the only thing we need to know is which circle theorem this is, where it's a quadrilateral with each of the points on the circle, so it's cyclic quadrilateral, and the circle theorem says that opposite angles in a cyclic quadrilateral add up to 180 degrees. So we just do 180 minus 65, which equals, I think, 115 degrees, so it'd be 115, and the response that they need is simply opposite angles in a cyclic quadrilateral. So opposite angles in a cyclic quadrilateral, I should write the whole thing. Opposite angles in cyclic quadrilateral add to 180 degrees. In most exams they're just looking for cyclic quadrilateral as a reason, and normally it's you'd write down it in just the first part of the question. It will say work out what x is and give reasons for your answer, and you just put in brackets cyclic quadrilateral, but it's always best to write too much than too little. Again, this question says y is directly proportional to the square of x. So to show proportional, we use this sign here. It looks like a fish, and it says that it's proportional to the square of x, so that's going to be x squared. Now to get rid of that fish, or alpha, whatever you would choose to call it, what we need to do is introduce a constant which we call k on the right hand side, like so. And actually a lot of students miss out that first step and just go straight to the second. Y equals kx squared. Okay, now that's our general formula, but we need to find out what k is. So we're going to go off to the side to find out what k is. And I'm going to put in the values of 50 for y and 5 for x. So 50 equals k times and then 5 squared. And let's put in my lines. So that's going to be 50 equals 25k. Divide both sides by 25. And 2 equals k, or k equals 2. So we found out what k is. So we'll go back to our formula, and we know that y equals 2x squared. Okay, the reason we know that is because k is constant, it won't change. So if it's 2 for that situation, it's going to be 2 across the board. It says find the value of y when x is 4. So we're going to substitute 4 into it. So y equals 2 times 4 squared. 2 times 4 squared, so that's going to be 2 times 16. 2 times 16 is 32, so y is going to be 32. Okay, first thing to realise with this question is that we've got an exponential here. An exponential is when x is the power, so it's y equals 2 to the power of x. So let's go through the graphs. Graph D is a linear graph because it's a straight line, so that's not correct. Graph A is a cubic because it goes up and then down and then up again. And we assume that the graph will carry on upwards here and carry on downwards here, but it's a cubic, so it's not that one. Graph C is a reciprocal, so it's something like this, or there might be some numbers in there, but it's not that one. Graph B, however, is our exponential. Now, the way of realising it's an exponential is that it kind of grows forever. So it starts off at a point. On this one, it starts off, technically, if you went to the left far enough, like infinitely far enough, you'd hit the x-axis, and then it goes up and up, and then at this point here, it hits 1, because anything to the power of 0, when x is 0, is going to be 1, and then it just shoots off upwards. So it's going to be graph B. Now there's a couple of ways of doing this question. We're asked to complete the table and then complete the histogram. You can do this by counting squares, but I'm just going to use the formula for this. And the formula, choose the right one. The formula has frequency at the top and frequency density and class width at the bottom. And it works the same way as most, or speed, distance, time, and all of those ones. So we know the class width, let's work out the class widths for these. That's going to be 40, that's going to be 40, that's going to be 20. And I'm just looking at the distances between the 80 and the 100, so I'm doing 100 take away 80. So the next one's going to be 40, and the last one is going to be 60. Okay, now I know that I do the frequency divided by the class width to work out the frequency density. So I'm going to do 44 divided by 40. So I'm going to divide that by the class width, which gives me 1.1. Now if I go to my diagram and label that as 1.1, because frequency density is on that axis, on the y-axis, then if I look down, well, I notice that that's going to be 1.0, 0.8, 0.6, 0.4, 0.2 and 0. So it works perfectly, and then obviously 1.2 at the top. So now I know my frequency densities, I can actually work out what the next frequencies are. So the next one has a frequency density of 0.6. So I'm going to times that by 0.6, because this is our frequency densities. Times that by 0.6, so I'm going to do 40 times 0.6, which is 24. The next one has a frequency density of 1.2, looking at the graph, or looking at the histogram, so 1.2. So I do 20 times 1.2, which is 24 as well. Okay, this time I've got to work backwards. So I've given the frequency and I've given the class width. So I need to divide them across. So divide that by 40 and divide that by 60 to work out the frequency densities. So 24 divided by 40 is going to be 0.6, and 36 divided by 60 is going to be 0.6 as well. Well, that's convenient. So they're both 0.6. So the first bar is going to be at 100 to 140, and it's going to be 0.6. So 140 is going to be there. And then the next bar is going to be 140 to 200. So it's a slightly longer bar there. And I'm just putting these off center so you can see them a little bit better. Now you don't need to shade these bars in, just draw them with a pencil and a ruler, and then that's it. Now this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now this equation here, up until this level, that used to be y equals 4x, and the question we have here would be, what is y when x equals 4? It's the same question, it's just a different way of writing it. So all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the g to the 16. So we've done the f, and the f we did first because it's closest to the brackets. So whichever one's close to the brackets you do first. Okay, we've done the f. Now we need to do the g, and we just do exactly the same thing. So g of 16, we're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay, perfect. Right, the next one. This time it's important to notice that the f and g are the other way around. So it's g that we're going to be doing first and then f. Now the thing we're feeding in is x. Well, you can't feed in x as x. Well, you can. It's just going to remain as x. So let's focus on the g first. So we're going to do g of x first. And now g of x is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now f wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the fg brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3. Now the major rule with algebraic fractions, or fractions generally, is that the denominators must be the same obviously at the bottom, that's where denominators are. They must be the same when you add or subtract. So we've got to make both of the denominators the same. So what I can simply do is times the left hand side by the right hand side's denominator and the right hand side by the left hand side's denominator. Basically I'm going to times both top and bottom of this side by x, and then both top and bottom of the other side by 10 plus x. So 11 times x over this 10 plus x by x as well. Now I've kept that fraction the same because I've times top and bottom by the same thing, so it's the same fraction. That's important that you don't change the fraction. Then I'm going to times the 5 by the 10 plus x, and I'm going to times the x by the 10 plus x. Now, something I've done instinctively, and a lot of people make mistakes on, is I put brackets around the expression 10 plus x, and if you don't do that, you will end up, say here, just timesing the x by the 10 and not timesing the x by the x on the right hand side. So always put expressions that are in fractions in brackets. Okay, so now the bottoms are the same, we can just simply add the tops, and I'm going to expand that top bit. So 5 times 10, which is 50, 5 times x, which is 5x. I'm going to expand the bottom, but you don't need to. So the bottom will stay as x brackets 10 plus x. The bottom, in fact, let's do that step first to make it really clear. Okay. So, and I'll put an equals there. Okay, now we've got 11x plus 5x, which is 16x plus 50, over, and I'll expand the bottom one, so it's 10x plus x squared. So my answer is 16x plus 50, and you normally do by powers of x, so I'm going to do x squared plus 10x. Now, unless it explicitly tells you otherwise, you don't need to expand brackets, so you could leave the bottom one in brackets, but I needed to expand the top one because I was adding the 11x on. So if it's literally like that, I wouldn't have needed to expand it. I could have just left it in brackets, but read the question because it might ask you to. Okay, so this question asks us to solve the quadratic equation. Now, if this comes up on the calculator paper, you can use the quadratic formula, but I'm not going to use the quadratic formula. I'm going to do this by factorizing, and I'm going to assume that either you've forgotten what the quadratic formula is, or it asks you explicitly to use factorizing, or it comes up on the non-calculator paper. First thing I need to do is factorize it. So I'm just going to write out the question again so I can just show it a little bit easier. Now, the method to factorize it, there are different methods out there, but the method I use is I times these together, and I'm going to put my answer over here. So 3 times 12 is going to be 36, and what I'm going to do is write factor pairs of 36, and the factors I'm looking for will add together to make the 20 here. So I want to make that 20. So 1 and 36 isn't going to work. We could try 6 and 6, well that's going to equal 12. However, 2 and 18, if you add them together they get to 20. So that's the right ones, those two are wrong. Next step is I need to split that 20x up into the 2 and the 18. So I'm going to rewrite this, and I'm going to split that 20x. Instead of 20x, I'm going to write plus 18x plus 2x plus 12 equals 0. Okay, now for this bit, I'm only focusing on the first bit, and the second bit separately. So I'm going to look at factorising them linearly. Okay, so I'm looking for something that goes into 3x squared and 18x. Well, definitely a 3 can come out of both of those, or divide out of both of those, and an x. So 3x squared divided by 3x is just going to be x. 18x divided by 3x, well 18 divided by 3 is 6, and x divided by x is just 1, so 6 times 1 is just 6. And then same thing again, so that's going to be 2 on the outside, and x plus 6. Now the bracket here needs to be repeating. If it doesn't repeat, then you've made a mistake, so that's a kind of hint to go back and check you're working out. And what we're going to do is we're going to grab the things on the outside of the brackets, and we're going to make a bracket with them. So 3x plus 2, which are the two underlined green bits. And we're just going to write down the repeating bracket once. And that's going to be our second bracket. Okay, so what we know with quadratics is we can get each of the brackets, as long as they equal 0, we can get each of the brackets to equal 0, and that will give us our solutions. So we're going to do 3x plus 2 first, so 3x plus 2, and we're going to equal that to 0. Put our lines down. So we're going to take away do both sides. 3x equals minus 2, and then we're going to divide by 3 both sides. Let's extend my lines a little bit. So x equals minus 2/3. And we're going to do the same with this one, slightly easier, because all we need to do is take away 6 from both sides. So our two solutions. Now it says that to us to round our answer to 2 decimal places. So the first one we don't need to, it's just minus 6. And the next one, well, 2/3 is 0.6 recurring. So that's going to be minus 0.67 to 2 decimal places. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator, you can just do 25 take away 13. If it's on an uncalculated paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right. The step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now, the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, all right, 35, it's 25. 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we've got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together.
Okay, so for this question you need understanding of sine, cos and tan graphs. This one's about sine graph, and you just need to know what it looks like. So point A, I know that the maximum a sine or cos graph go to is 1, and a sine graph reaches that at 90 degrees. So it's going to be 90 on our x-axis and 1 on our y-axis. At point B, I know it gets there to 0 at 180, because it's 360 in total, and it reaches that 0 point halfway. So it's going to be 180 across and 0 up. Now this is quite a tricky question really. This is about graphic transformations, and there's 3 parts of this, A, B and C, and we've got to figure out, well, what's looking different with this cos graph. Well, cos normally, if I just sketch one out, normally starts at 1, goes down to 0, goes down to -1, and then goes back up to 1. And it does that at 90 degrees, 180 degrees it reaches its minimum, 270, and then 360 it goes back up to 1. So it's between 1 and -1. Okay, so what's different? Well, it's slightly higher up, it's more stretched out upwards, and it's compressed to the right. Okay, so let's have a look at B first. Now, the function within, or the number within a function will affect the stretching on the x-axis. So let's have a look. Well, it normally has kind of one circuit or one period between 0 and 360. On this one, it has one here. It then does the whole thing again, and then it does the whole thing a third time. So the B is going to be 3 because it does it 3 times. Now, it might seem a bit odd that it seems to be getting compressed the higher B is. So if B was 4, it would be even more compressed. it kind of works the opposite way around within the function, within the cos, because basically at the point here, which is going to be, I think, 120, if you think about it, you type in cos 120, and then before you type in, you type in 120, but before you type in the cos, you times it by 3. The cos will think you're at 360, so it will be going up to 1 again. Anyway, okay, so that's the first bit done. So b is 3. Now, if it stretched out, say if cos looked like this, then it would be a half. So if you're only getting half a kind of full rotation, a full circuit, a full wave, whatever you want to call it, then it will be a half. Okay. The next two are quite easy because you can see on my diagram here we're between 1 and -1 normally, which is 2. Okay, and on this one between 3 and -1 we're now 4. So we've had to times it by 2 to kind of stretch it out. So we've had to times it by 2, so a is going to be 2. But you would think, well, hang on, if we times it by 2, then it should be between 2 and -2, but it's not. It's kind of moved up 1, and the reason for that is because we've added 1 onto it. So c is going to be 1 because it's just shifted 1 up. Not the easiest question in the world, however, with a bit of practice, you'll get there.
Okay, so this doesn't seem like the easiest questions because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4/3, I can just say 2/3, which is half of 4/3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x. And the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that a hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder, wow, tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'm going to put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2, equals x over 50. So our answer is h equals x over 50.
This question might just ask you to rationalize the denominator. It might ask this question the form that's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalizing means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalizing means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want. First outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. and root 5 times minus root 5, well, a positive times a negative is a negative, and any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58.
I hope you enjoyed that video. If you like what you see, please click subscribe and then you'll get notified on all the content we put out. Also, check out our YouTube channel. We've got all the topics in the Maths GCSE collated by grades, by topic, by tier. We're finding that it's really useful resource. I think we've got hundreds and hundreds of videos. They're tiny little videos on each tiny little topic, which students are finding useful. Don't forget to check out the website as well. Everything on the website, all the online papers, everything we put out on the website is completely free. And also don't forget, if you really like what you see and you want to support the site, please click this link now above me, and that will take you to the supporters club. Thank you very much.